Today we'll introduce a project management tool called Maven, which has become the project management / build tool for Java projects. But first, let's understand what is build. Build is a word you'll probably hear quite often in software development. For example, in Eclipse menu, you'll see commands like build all, build project, build working set, build automatically, and so on. So what is build? For some people, build simply means compile, which is not wrong per se, especially for small projects where all you have is some source code. But in general, build refers to the process that transforms a project from its original form, which may consist of source code files like Java files, metadata files like configuration files, resources like images, icons, and style sheets and library files, and then turn them into a format that is ready for execution, distribution, or deployment. For example, a build process may produce an exe file that can run on Windows, or a jar file that can be used by other Java projects, or an APK file that can be installed on an Android device, and so on. Although compiling source code is an important part of build, a build process often involves other things as well. For example, as we mentioned in the Java annotation lesson, software tools can use annotations like web service and web method to generate additional source code. And this obviously needs to happen before compilation so that the generated code can be compiled too. And speaking of post-processing, later when we discuss the object relational mapping framework Hibernate, we'll see that after Java code is compiled into class files, Hibernate can process the class files to extract information about how Java objects are mapped to relational tables. Another post-processing example is the linking step in the programming language C. In this step, multiple compiled source files called object files are linked together into a single library or executable file. After post-processing, as we mentioned in the previous slide, the build process may need to package the project into a format that can be executed, distributed, or deployed. And in fact, deployment itself can often be considered as part of a build process. For example, later in the course, we'll see how to package a Java web application into a WAR file and automatically deploy it to a remote server. Okay. So the build process is very important and sometimes can be quite complex. So it's not surprising that people have been developing and using tools that help making the build process more automated and more efficient. Many of you probably have heard of or have used build tools before, like Make or Ant. Today we'll see a new build tool called Maven. And Maven has replaced Ant to become the de facto standard build tool for Java projects. It should be pointed out that Maven considers itself more than just a build tool. Officially, it calls itself a project management tool. Later, we'll introduce some Maven features like project object model, project lifecycle, dependency management, plugin framework, and so on. And you'll see that there are some good reasons for this distinction. We'll start with a simple example and see how we can use Maven. Here, I have a simple project called Maven example or MVN example. And under this project, I have a file called pom.xml and some source code. The source code is under the folder source or src, and if we look under that, we can see that there's actually only one Java class in the project, is under the folder source main Java CS520 example. And if we look at that, class, we can see that the class is a very simple class, just has one line that prints out hello Maven and so on. So there's nothing really much to say about the code itself. The important thing, of course, is this pom.xml file, which looks pretty simple too. As you can see, it only has a few lines, and this pom.xml file, I have put it here to make it look more clear, and this is exactly what it looks like. So what can we do with this project? Well, we can compile it, and to do that, we'll say mvn compile. And it will do something. And if we look at this project again, we can see that there's now an additional folder called target. And if we look at the target folder, we'll see that under target folder, it has created the classes folder, and under classes folder, it has put the hello, compiled hello class in there. Under CS520 example, that's the package of that class. So that conforms to the directory structure for Java packaged class. And we can do something more. So we can say mvn package. Again, something happened. If we look under the target folder again, we can see that it created some additional files. In particular, there's now a file called Maven example-1.0.jar, and that's the jar file that's created from the compiled classes. In our case, we only have one. So it looks pretty simple, and now let's understand what's going on here. First, we have this pom.xml file. POM, P-O-M, stands for Project Object Model, and the pom.xml is a complete description of a Maven project, in the sense that if I give you a pom.xml, you will know exactly how to build this project. This may seem like a pretty lofty claim, especially if you think about how complex some build processes can be and how simple this file looks. But after I explain it, you'll see why. First, we notice that this is an XML file with some text like project, model, version, group ID, artifact ID, and so on. You can think of this text as a language, kind of like the HTML language that you are familiar with. And this language is used to describe a project instead of describing a web page like with HTML. The model version tag is simply used to indicate the version of the language being used. Pretty much like when we say HTML4 or HTML5, with 5 or 4 being the version of HTML, and this model version thing is essentially the version of the language that we are using to describe a project. The next three tags, or by the way, tags in XML are usually called elements, so sometimes I use these two terms exchangeably. And the next three tags or elements are quite important. Group ID, artifact ID. They are part of the so-called Maven coordinates. You can think of Maven coordinates as a unique identifier of a software project. Just like using XYZ coordinates, you can uniquely identify a point in a three-dimensional space. The idea is that you can use Maven coordinates to uniquely identify a software project in the universe of all software projects. And like in 3D coordinates where you have X and Y and Z, there are several components in Maven coordinates as well. Group ID is used to represent the company or the organization that developed the software. It usually uses the reverse URL naming convention similar to Java packages. For example, if I release some software, the Maven group ID for my software would probably be edu.csula.cs. And the artifact ID is basically the project name. For example, for my project, let's say I created a project called Chrome, and the artifact ID for that project would be Chrome. Note that the combination of the group ID and the artifact ID should be unique, and this way nobody would confuse my project edu.csula.cs.chrome with Google's Chrome project, which presumably would be called com.google.chrome under Maven. The other three coordinates further distinguish among different releases within the same project by version, by packaging format, and by some classifier. For example, if you release your software for both 32-bit Windows and 64-bit Windows, the two releases will have the same group ID, artifact ID, version, packaging, except that one would have a classifier x32 and the other one having a classifier x64. Among these coordinates, the first four are required, though packaging can be omitted because it has a default value jar. The classifier coordinate is optional. So if we go back to our example, we can see that this POM file just has the coordinates of the project and really nothing else. So how come we can use this to compile and package the project without telling it what files we want to compile and where those files should be? Well, the answer is simple: defaults. Like many other things these days, Maven practices convention over configuration, which basically means using lots of defaults. To see the defaults used, we can create a simple Maven project in Eclipse and see how it looks. So to do that, just create a new project and pick the template under Maven that's called Maven project, and check this option that says create a simple project. To create a project, we must provide the coordinates for the project. So I'll use edu.csula.cs as my group ID, and the artifact ID of project name, I'll call it Chrome, and all the other fields can be left empty. If we click on pom.xml, you can see that Eclipse gives you several so-called views of this file, and each view is shown on a different tab. If you click on the last tab that says pom.xml, you can see how this file actually looks like. So this is the actual content of this file, and these tabs are simply different views of this tab. As you can see, this pom.xml file looks pretty much like our previous example here. It only has the model version and the coordinates of the projects. But if you look at the effective POM, you can see all the defaults used by Maven, and there are lots of them. In other words, this simple POM file is actually equivalent to this one with all the defaults explicitly specified. Obviously, no one can remember all these defaults, but one default you must remember and understand is the default directory structure used by a Maven project. Under Maven, a project is organized in certain directory structure, and this is how Maven can find source code files and know where to put the compiled class files and so on. By default, under the project folder, there are two folders called source and target. As we have here, SRC and target. As the name suggests, one is for source files and the other one for files generated during the build process. Under source, there are typically two folders, main and test. Main and test. And again, as the name suggests, main is for regular files and the test is for files related to testing. Under main, the Java folder is of course for Java source code, and often there are also some other folders like resources for resource files and web app for web application files like HTML and JSP pages. Note that in a web application, when we talk about resources, we typically mean things like images, style sheets, and so on. But in Maven, the meaning of resources is a bit different. In Maven, files under resources means the files that need to go under class path. Those files are typically configuration files and property files, so don't confuse Maven resource files with web application resource files. There are two more things I want to mention about the directory structure. First, not every project has to have all the folders. For example, in our example, we don't have the test folder under source, we don't have the web app or resources under main, and we didn't even have the target folder before we run the build. And that's perfectly fine. Not every project has to have all the folders. Secondly, it's very important that you understand and follow the default directory structure. Although you can configure Maven to use essentially any directory structure you want, sticking to the default is a lot easier for you and a lot easier for other developers as well if they need to work on your project. So understand the default directory structure and use it if it at all possible. Okay, now we understand how the project is organized and what the pom.xml file is about. Let's look at how to build a project. In particular, what happens when we say, for example, type maven compile? The answer is that Maven will go through each phase of the build lifecycle up to the compile phase and run the operations associated with each phase. Of course, to understand this answer, we need to first understand what is a build lifecycle and what are the operations associated with a build lifecycle phase. in addition to the project object model, or POM, which is used to describe a project, Maven also defines several build life cycles. As we can see here, there's a clean life cycle, which describes the process of cleaning a project, and the site life cycle, which describes the process of creating a documentation site for a project. The most important life cycle is, of course, the default life cycle. As we can see, the default life cycle describes the process of building a project as a sequence of steps called phases. For example, it starts with a validate phase, then initialize phase, then generate sources phase, process sources phase, and so on, all the way to deploy phase. At this point, you may be thinking, hey, my project is not this complex and it doesn't have all these phases. Again, that's perfectly fine. Not all projects need to use all the phases. For a particular project, you can use just the phases you need, and by using a phase, I mean associating some operations with that phase, and then simply leave other phases empty. For example, by default, Maven associates a resources operation with the process resources phase, and the compile operation with the compile phase. Note that other phases like validate, initialize, generate sources, and so on are empty, in the sense that there's no operation associated with them. When we type Maven compile, Maven will go through each phase of the build cycle, starting from the first one, validate, up to the one specified in the command, which is the compile phase in this example. At each phase, Maven will perform the operations associated with that phase. Of course, nothing happens if a phase is empty like this. It will continue up to the phase that is specified in the command. And in this example, Maven will only perform two operations. The resources operation in the process resources phase. This operation basically just copies the files and their source main resources to the class path. And then the compile operation in the compile phase, which compiles the Java source code. Looking at all the phases in the build lifecycle, you can imagine that instead of Maven compile, you can say Maven initialize or Maven process resources or something like that. So basically, the command here is essentially a build cycle phase. And by specifying a build cycle phase, you are instructing Maven to go through the build cycle from the beginning up to that phase and perform the operations associated with each phase along the way. Now, the last remaining questions are related to those operations. What are these operations and how do we associate them with a certain phase? In Maven, operations are provided by plugins. A plugin may implement one or more operations, and these operations used to be called modules for whatever reason, but these days the official name is goals. You can see some of the Maven plugins on this page. For example, you can see there's a compiler plugin, a resources plugin, a site plugin, a Surefile plugin for testing, and so on. If you click on a plugin, you can further see the operations implemented by that plugin. These operations are, by the way, called goals. For example, the compiler plugin provides two goals. One is called compile, and this goal is bound to the compile phase, or in other words, this operation is associated with the compile phase. This plugin also provides a test compile goal or / operation, and this operation or goal is bound or associated with the test compile phase. Here's how we can include a plugin in the POM file of a project. First, we specify the coordinates of the plugin. Just like any software project, a plugin has its own coordinates, so Maven can load the right version of the right plugin. We then specify the goal, which is the operation, and then specify the build cycle phase in which this operation is to be performed. There is also a configuration section that you can use to customize the behavior of a goal. For example, you can tell the compiler plugin to generate Java 1.7 class files, so you can deploy your application on a server that runs JDK 1.7 like the CS3 server. Note that some plugins like the compiler plugin are included by default, so most of the time you don't need to explicitly include them in your pom.xml, as in this example. But sometimes you may want to change the behavior of some default plugin or use some plugin that is not included by default. In those cases, you need to specify the plugin explicitly in pom.xml like this. For a more complex example, please check out the pom.xml file in the CSNS2 project. And it looks like this. And if you scroll down a little bit, you can see that it includes a bunch of plugins here with some explicit configuration of how those plugins should behave. To recap, to run a Maven build on command line, you can say Maven, then the name of a phase, and then Maven will go through each build cycle phase up to the specified one, and in each phase execute the goals bound to that phase. This is how you can run a Maven build on command line, and in Eclipse you can do the same thing using the Eclipse GUI. For example, let's say we want to run a build of this Chrome project. So just right-click on the project, select Run As, and then choose Maven Build. Notice that here there are already several builds included in the menu. For convenience, if the build or the phase that you look for is not in there, you can click on this one and create your own. You can give a name for this build. The name doesn't really matter, and the goals here are essentially the name of the build cycle phase. Let's say for whatever reason we want to run a build up to the process classes phase. Is that a real phase? Yeah. So let's say we want to run up to this phase. And You can give it any name. I'm just going to call it Chrome build. There's already build with that name. I'll just call it Chrome 2 then. And then we can click run. And something happens here. It says build success. That's great. Although we know that we didn't bind any goals to that process classes phase. So really it's just you're running compilation stuff. But you'll see how this thing works. Okay. Now we understand how Maven works. Let's go back to a more fundamental question. Why? Why use Maven in the first place? In particular, you may be wondering that modern IDEs like Visual Studio and Eclipse can usually build our projects just fine. So why do we need a separate build tool like Maven? The answer is actually you don't. If your IDE can actually do everything you want. The problem is that often there are things in a build that are not supported by the IDE. For example, what if you want to deploy a web application to a remote server? What if you want to generate some source code from some metadata files or create a zip package of selected files to submit as your homework submission? If you do this type of things as part of your build process, but your IDE doesn't support them, you'll need a build tool like Maven or Ant or Make. These build tools, in a sense, are like mini programming languages. You can essentially use these tools to program the operations you want and incorporate them into your build process. So if we agree that build tools are necessary, then the next question is why do we choose Maven over other build tools like Ant, for example? Well, here's a list of things that, in my opinion, makes Maven better than the alternatives. First, Maven has become the de facto standard for Java build tools. Because everybody knows it and uses it, it's good for us to use it because it makes it easier for other developers to understand our projects and vice versa. The second reason is that by defining the project object model, the POM, and the build life cycles, Maven standardizes a way to describe and build a project. This is actually quite significant. Because the build process of a project can be very complex. If you are a developer trying to maintain or contribute to an existing project, it can take lots of time just to understand how to build a project. With Maven, all the projects use the same project description, the POM file, and follow the same build life cycles. This makes it a lot easier to understand the existing project, and it's a very important advantage over other build tools. The next three things are my personal favorites: archetype, dependency management, resource filtering. Resource filtering in particular is actually a relatively minor feature, but well, I like it, and this is my class. Anyway, let's see what they mean and how they help development. Archetypes are basically project templates, which are very similar to Eclipse project templates like the dynamic web project we are familiar with. The nice thing about Maven archetype is that you can create and share your own project templates as Maven archetypes. This is quite useful if you need to work on lots of small projects with similar structures, or if you work for a company that requires all company projects use certain libraries and settings. Unfortunately, at the time when I recorded this lesson, there seemed to be some problem with the online Maven archetype catalog. So if you want to create a project in Eclipse from a Maven archetype, you may run into some problems. Despite this, I think archetype is still a very useful feature, and I'm sure they will fix the online archetype catalog very soon. If archetype is a useful feature, then dependency management would be a killer feature of Maven. A dependency here means a library that the project depends on. Remember that in classes like CS320, when you need to add a library like a MySQL JDBC driver to your project, you had to go to a website, download a zip file, unzip it, pick the right jar file out of the unzipped files, and then add the jar file to a project. Well, with Maven, it's a lot easier. In fact, all you need to do is adding the coordinates of the library to the POM file, and that's it. Behind the scene, Maven will download the library from a central repository and add it to your project. The downloaded library is also stored locally on your computer, so if next time another project needs the same library, it won't need to be downloaded again. If you do this in Eclipse, it's even easier, as Eclipse has a search feature that lets you to search for the dependency without knowing the exact coordinates of the dependency. For example, let's say if I want to add the MySQL JDBC driver to my Chrome project. So I would click on pom.xml, go to dependencies, and then click add. I don't know the exact coordinates of the dependency, so I just search MySQL, and you can see a bunch of them come up, and most of them don't look like what we are looking for. They are not from MySQL or Oracle or anything, so we can skip all of them, and yeah, it's this one. So as we can see, this is the JDBC, MySQL JDBC driver we are looking for. Simply pick the version we want and say OK, and then that's it. There's no going to a website, downloading zip file, unzip, and all that, and Maven takes care of all that in the background. If we look at the pom.xml file, we can see that what happens is Maven simply includes this dependency in the pom.xml file with the coordinates of the dependency, and everything else is automatically taken care of. The library now become part of our project. Maven's dependency management feature actually goes beyond just downloading a dependency. In particular, it does two very useful things. First, it automatically includes the dependencies of a dependency. For example, if your project relies on a library A, but library A itself relies on another library B, and that library B in turn relies on a different library C, then all you need to do is include library A in your POM, and then Maven will automatically get B and C for you, and that obviously is quite convenient. Another useful feature of dependency management is automatic dependency conflict resolution. For example, if library A relies on version 1 of library B and library C relies on version 2 of library B, Maven is smart enough to figure out that the newer version of library B should be included. To see how these features work, again check out the POM file in the CSNS2 project. Here, first click on the Dependencies tab and see what dependencies we have included explicitly. Well, there are quite a few of them. And then look at the Dependency Hierarchy tab and see what additional dependencies Maven has included for us. For example, notice that we have included a dependency called Spring Web MVC. And here it shows Spring Web MVC, but it also shows that Maven automatically include included a second dependency, Spring Beans, because Spring Web MVC depends on Spring Beans, and in turn, it also included a third dependency, Spring Core, which is a dependency for Spring Beans. We do not need to explicitly include Spring Beans, Spring Core. Those dependencies are automatically figured out and included by Maven. Another thing to notice is that for many dependencies, there's a note here that says omitted for conflict with another one. There are two types of conflict. For example, here it says Spring Core 3.28 omitted for conflict with 3.28, and that's actually here. Notice that this dependency, Spring Core 3.2.8, are included twice, and Maven noticed that, so it avoids duplicate dependency by omitting this one and only include this one. So there are no duplicate dependencies in the project. And if we look down here, we can see a different example like this. In this example, you can see that there's a dependency called JCL-over-SLF for J. We'll explain SLF for J and those type of things when we get to the logging part of the class. But notice that the dependency here is version 1.5.8, and it said that it's omitted for conflict with 1.7.5. In other words, Maven figured out that the 1.7.5 is a newer version, and when there's a conflict of two dependencies of different versions, the newer version will be picked automatically. And if you want to see how the POM file looks, check out the POM file on this tab, and you can see that the dependencies are listed here, just like here. And that's for dependency management. And the last feature I want to mention is resource filtering. Basically, what this feature does, it allows you to use placeholders like this in your project files, and later during the build process, actual values like this can be used to replace these placeholders automatically by during the Maven build process. As I mentioned, it's a somewhat minor feature, but it's quite useful, especially for Java web applications where there are usually lots of parameters scattered around in many different metadata files. With resource filtering, you can put all the parameters in one file, like the build.properties file in the CSNS2 project, and then use resource filtering to let Maven to insert these values into the right configuration files. This makes it a lot easier to manage these parameters, especially when you're working a team where each developer has a different development environment. To summarize, we covered these Maven concepts: POM, coordinates, life cycles and phases, plugins and goals, archetype, dependency management, and resource filtering. I like Maven a lot and hope you will too. To learn more about Maven, please check out some books by Sonatype. This is a company that is behind the development of Maven.